Our planet is a tapestry of interconnected systems, a delicate dance of air and water that shapes life as we know it. The Earth's climate is a complex and dynamic entity, influenced by a myriad of factors that interact in ways both subtle and profound. From the gentle breezes that rustle the leaves to the mighty storms that sweep across continents, every element plays a part in this grand symphony. Within this intricate ballet, the El Niño Southern Oscillation, or ENSO, plays a pivotal role. ENSO is a recurring climate pattern involving changes in the temperature of waters in the central and eastern tropical Pacific Ocean. It is one of the most significant climate phenomena on Earth, influencing weather and climate across the globe. This naturally occurring climate pattern, with its alternating phases of El Niño and LaNiña, exerts a powerful influence on global weather patterns. El Niño and LaNiña are opposite phases of the ENSO cycle, each bringing distinct changes to the climate. El Niño is characterized by warmer than average sea surface temperatures in the central and eastern Pacific, while LaNiña is marked by cooler than average sea surface temperatures in the same region. While El Niño brings warmth, LaNiña, its cooler counterpart, ushers in a different set of changes, rippling across the globe. LaNiña events typically bring cooler and wetter conditions to the western Pacific, including countries like Indonesia and Australia, while causing drier conditions in the eastern Pacific, affecting regions such as the southwestern United States and parts of South America. Imagine a vast ocean, its surface a canvas for the sun's warmth. The Pacific Ocean, the largest and deepest of Earth's oceanic divisions, plays a crucial role in the ENSO cycle. Its vast expanse and immense volume make it a significant driver of global climate patterns. This is the Pacific Ocean, a key player in the ENSO cycle. The interactions between the ocean and the atmosphere over this vast body of water are central to the development and evolution of El Niño and LaNiña events. During LaNiña, the trade winds, those relentless streams of air that circle the equator, strengthen their grip. These winds blow from east to west across the equatorial Pacific, pushing warm surface water towards the western Pacific and allowing cooler water to upwell in the eastern Pacific. They sweep across the Pacific, pushing warm surface water westward towards Indonesia and Australia. This movement of warm water is a key feature of LaNiña, contributing to the cooler sea surface temperatures in the central and eastern Pacific. As the warm water migrates, cooler water from the depths rises to replace it along the South American coast, a process known as upwelling. Upwelling brings nutrient-rich waters to the surface, supporting marine life and influencing local weather patterns. This shift in ocean temperatures, a seesaw between warm and cool, is the hallmark of LaNiña. The changes in sea surface temperatures can have far-reaching effects, influencing weather patterns, ocean currents, and even the distribution of marine species. But its effects extend far beyond the Pacific, reaching every corner of the globe. LaNiña can influence weather patterns in distant regions, contributing to phenomena such as increased hurricane activity in the Atlantic, altered monsoon patterns in India, and even changes in the jet stream that affect weather in North America and Europe. Understanding LaNiña and its global impacts is crucial for predicting and preparing for the diverse weather conditions it can bring. To truly grasp LaNiña's impact, we must delve deeper into its mechanics. LaNiña, which translates to the girl in Spanish, is a complex climate phenomenon that significantly influences global weather patterns. It is the counterpart to El Niño, and together they form the El Niño Southern Oscillation, ENSO, cycle. Understanding LaNiña requires a closer look at the intricate interplay between the ocean and the atmosphere. Picture the Pacific Ocean as a giant swimming pool. In this vast expanse of water, the surface temperature plays a crucial role in determining weather patterns. The Pacific Ocean covers more than 60 million square miles, making it the largest and deepest ocean on Earth. Its sheer size means that any changes in its temperature can have profound effects on the global climate. When the trade winds blow strongly during LaNiña, it's like someone is constantly pushing the warm water at the surface towards one end. These trade winds are easterly winds that blow from east to west along the equator. During LaNiña, these winds become even stronger, intensifying the movement of warm water across the Pacific. This creates a buildup of warm water in the western Pacific, while the eastern Pacific experiences an influx of colder water from the depths. This process is known as upwelling, where cold, nutrient-rich water rises to the surface. The contrast between the warm and cold water is stark, and it sets the stage for significant climatic changes. This temperature difference between the east and west is crucial. It creates a thermal gradient that drives atmospheric circulation patterns. The warm water in the west heats the air above it, causing it to rise and create low-pressure systems. Conversely, the cold water in the east cools the air, leading to high-pressure systems. It disrupts the normal atmospheric circulation patterns, leading to a cascade of effects around the world. These disruptions can alter the position and strength of the jet stream, which in turn affects weather systems far beyond the Pacific region. The impacts of La Niña are felt globally, influencing everything from monsoon rains in India to drought conditions in South America. The warmer western Pacific fuels the formation of towering thunderstorms and increased rainfall, while the cooler eastern Pacific experiences drier conditions. This dichotomy can lead to extreme weather events, such as floods in some regions and droughts in others. The increased rainfall in the western Pacific can also enhance the risk of tropical cyclones and hurricanes. These changes in atmospheric pressure and wind patterns have far-reaching consequences. They can influence agricultural productivity, water resources, and even the frequency and intensity of natural disasters. Understanding these patterns is crucial for predicting and mitigating the impacts of La Niña. The jet stream, a fast-flowing air current high in the atmosphere, is pushed northward, altering storm tracks and influencing weather patterns across the globe. This shift can lead to unusual weather conditions, such as unseasonal cold spells or heat waves in various parts of the world. By studying La Niña, scientists can better understand and predict these complex interactions, helping societies to prepare for and adapt to the changing climate. From the lush rainforests of the Amazon to the arid landscapes of Australia, La Niña's influence knows no bounds. Its effects are felt across continents, impacting weather patterns, ecosystems, and human societies alike. In Asia, La Niña can disrupt the monsoon season, a vital source of rainfall for agriculture. The Indian subcontinent, heavily reliant on monsoon rains, can experience delayed or reduced rainfall, leading to droughts and crop failures. Meanwhile, countries like Indonesia and the Philippines may see increased rainfall, leading to flooding and landslides. Across the Pacific, La Niña brings cooler and wetter conditions to the Pacific Northwest of North America, increasing the risk of flooding and landslides. Conversely, the southern United States often experiences warmer and drier conditions, increasing the risk of wildfires and drought. Section 4, La Niña in 2025. A glimpse into the future. As we look ahead to 2025, scientists predict a moderate La Niña event, which is characterized by cooler-than-average sea surface temperatures in the central and eastern tropical Pacific Ocean. This phenomenon can have significant impacts on global weather patterns, influencing everything from rainfall to temperature extremes. With a 74% chance of it developing during the winter of 2025 to 2026, La Niña's presence is likely to be felt across various regions. Meteorologists are closely monitoring the situation, using advanced computer models and historical data to make their predictions. While the exact impacts are still uncertain, we can make some educated predictions based on historical patterns and current climate models. These models take into account a wide range of variables including ocean temperatures, atmospheric conditions, and even solar activity to provide the most accurate forecast possible. In North America, the northern tier including Canada and Alaska may experience a colder and snowier winter. This could lead to increased snowfall, which might be beneficial for water resources in some areas, but could also pose challenges for transportation and infrastructure. Meanwhile, the southern states brace for warmer and drier conditions. This shift in weather patterns could exacerbate existing drought conditions, making water conservation efforts even more critical. The already parched Southwest may face even more severe drought, straining water resources and increasing the risk of wildfires. These conditions could have far-reaching effects on agriculture, wildlife, and local communities. Strained water resources and heightened wildfire risks are significant concerns. Firefighters and emergency services are preparing for what could be a challenging season, with efforts focused on prevention and rapid response to any outbreaks. Australia, after enduring the scorching heat of the 2023 to 2024 El Niño, may find some respite with La Niña's cooling influence. This shift could bring much-needed relief to regions that have been battling extreme heat and drought. The cooling influence of La Niña may lead to increased rainfall in some parts of Australia, transforming dry landscapes into lush, green areas. This could benefit agriculture and water supplies, providing a welcome change from the harsh conditions experienced during El Niño. However, the eastern states could see increased rainfall, potentially leading to flooding. Communities in these areas will need to be vigilant and prepared for the possibility of heavy rains and rising floodwaters. While the West grapples with continued dryness, the contrast between regions highlights the diverse impacts of La Niña. Each area will need to adapt to its unique challenges, whether it's managing excess water or coping with a lack of it. Section 5. A Tangled Web: La Niña and the Shifting Climate. La Niña's dance is not performed in isolation. Climate change, driven by human activities, is altering the very stage on which this natural climate pattern unfolds. While La Niña typically brings a temporary cooling effect, the planet is still warming at an alarming rate due to greenhouse gas emissions. The relationship between La Niña and climate change is complex and still not fully understood. Some studies suggest that climate change may increase the frequency or intensity of La Niña events, while others suggest the opposite. What is clear is that rising global temperatures are amplifying the impacts of these natural climate fluctuations. Even during La Niña years, extreme weather events such as heat waves, droughts, and floods are becoming more frequent and intense. The delicate balance of Earth's climate system is being disrupted, with potentially devastating consequences.